Good day to Dr. Hazirah. My name is Poh Tsu Wang. The title of our project is Beach Cleaning Machine. So in this group, there are 5 members, which is me, Poh Tsu Wang, Hazirah, Binti, Roslan, Yeong Sook Yee, Kai Boon, and Chuan, Ting. So I'll be explaining the introduction and the literature review. First is the background of study. So beach litter is a growing worldwide environmental problem now. And beach cleaning machine is created to collect beach litter. And the concept of this project is to find solution to save beach environmental that garbage and litter is affecting the beach environment. Next is the design brief. So environment of beach in Malaysia are often spoiled by litter and garbage, and the cleaning cost is high and process is tedious. So our group is going to design and build a beach cleaning machine to solve the above problem. So there are some constraints such as the machine might sink during operation and whether the machine can work under high temperature. And we are going to design the machine in unique and can remedy all the constraints. So the objective of our project is to design a beach cleaning machine which could save time and work effectively, and to design a beach cleaning machine which have the function to perform sand filtering for the rubbish. Next is the scope of our project. The scope of our project is to study the research background of beach cleaning machine in various kinds of aspects, including the condition of beach, survey project, effectiveness of functionality of beach cleaning machine, to study and review the existing pattern and product of the beach cleaning machine which is available in the market, to generate an individual sketches with 3 concepts, to generate the modified sketches from the champion of the evaluation metrics as datum, to choose or select the best design from the concept of member by using parts metrics, to evaluate the final concept by using engineering tools and technique, including the FMA, FMEA, and engineering analysis. And lastly, to generate the detailed documentation of the final design by using SolidWorks software. Next is the literature review and the research background. We have 5 research background, which is the customer usage targeted market, human cost of beach pollution, the survey project, effectiveness of the functionality of beach cleaning machine, and beach surrounding condition. First is the customer usage and targeted market. So the mechanical beach cleaning machine market is rising due to increasing the environmental concerns among people. And beach cleaning equipment market in Asia Pacific region is expected to benefit from rapid urbanization and rising demand for dirt-free beaches near the sea. And also growing urbanization in emerging countries and increase the income of consumer. Also, the high cost of beach cleaning equipment is expected to hinder. Next is the human cost of beach pollution. The first one is the litter and garbage such as cigarette butts and food wrappers and plastic bottles are always left by people on the beach. And next is the nutrient pollution. The overabundance of nitrogen and phosphorus can impact on environment and human health. Also, the animal waste spilled from the storage structure into waterway during the storm. The next is the stormwater runoff. As the water travels over the sidewalks, parking lot, and other places, it peaks and accumulates pollutant including trash, chemicals, oil, and dirt. Next is the survey project. The first one is the Prometeo beach cleaner robot. And the next one is the garbage collector robot on the beach using wireless communication. And this is the modular robot and robot mission and the HS Greenfish beach cleaner robot. And these are the survey project for our reference to design our beach cleaning product, beach cleaning machine. And this is a swap board of the beach cleaning machine. The next is the effectiveness of functionality of beach cleaning machine. The first one, we have 5 parts. The first one is the prime mover, which is the method to remove the machine. And the second part is the collecting. The collecting is the method to transfer the rubbish from sand to rubbish container. The next is the conveying, is the method to transfer garbage from beach to garbage container. The next one is containing. Containing is the method to store the garbage. And finally, removing. Removing is the method to remove garbage from garbage container. So, and the next is the beach cleaning, beach surrounding condition. Is as the stand condition, sand size, and the climate change. The climate change such as the sea level will rise due to climate warm, and so the sea water will increase. Next is the review of existing product and pattern. And these are the pattern and existing product me and my team member has found. And the first one is the walk behind the beach cleaner, as shown in the diagram. Next is the beach cleaner machine under US patent US 5184916A, and this diagram is the perspective view of the machine in accordance with the invention. And this is the schematic perspective view of part of the machine. And this is the side view in evaluation showing a front part of the machine in operative position. And next is the beach cleaning machine under patent US 2733904A. And this is the partially side view of beach cleaning machine. And this is the front view of a broken part of beach cleaning machine. And this is the top view of beach cleaning machine. And this is the top view of some parts which are partly invisible in the machine. And this is the efficient beach sweeper beach cleaning machine. And these are the different view of the efficient beach sweeper beach cleaning machine. And next is the pattern beach cleaning machine US 5652992A. And this is the simplified diagram of a preferred embodiment of the invention employing a conveyor belt cooperate with a sweeping brush. Next is the simplified diagram of a preferred embodiment of the invention adapted for use with a single belt, which having a power drive using a gear track mounted on its inner surface. The next is the beach cleaning machine pattern US 2093148. And this is a side elevation of the forward parts of the machine. And this is a side elevation of the rearward part. And this is a plan partly broken away from the forward part. And this is a plan partly broken away from rearward part. And this is the front elevation of the forward part. And that's all for me. Thank you. Next, I would like to invite my next teammate for the PDS explanation.
Assalamualaikum. My name is Hazirah Binti Roslan. So I will present about the product design specification, or we call as PDS. So for performance, the machine must be able to collect waste such as bottle, water, cigarettes, and so on. So the speed for motor for conveying is approximately 900 RPM, and the power of motor approximately is 1.5 kilowatt. For the maximum waste for the load is around 10 kilogram per operation, and the effectiveness such as production rate, volume flow rate should be high, and the speed of beach cleaning machine is around 20 km per hour. And the last one for the performance is this beach cleaning machine can be fully automatic, auto controlled by the controller, or semi-auto or manual push the machine to operate. For the cost is around 1,100 is the maximum cost, including manufacturing cost and material cost. For the quantity is 1 unit, and the size length not to exceed 1,000 millimeter. The width not exceed 1,000 millimeter, and the height not to be exceed 1,400 millimeter. For the weight, maximum allowable weight for the product is around 25 kilogram. And the material that we choose is this machine can be made for any material as long as they are strong, rigid, rust resistant, environment friendly. For product lifespan, around 10 years to stay on the market, and the customer that we target is beach cleaning organization, beach cleaner, and volunteer community. The demand for beach cleaning machine is increasing due to it help to save time on handle management of waste. For the patent that had our product from be developed is a US patent number 2093148 and US patent number 3596717. For service life, the product can be last for 10 to 15 years and 8-hour operation time per day for every working day. For shipping, the machine will be shipped by container lorry within Malaysia, and the shipping cost is based on where the location of the buyer. For the environment, this machine is environment friendly, resistant to corrode, water, dust, wind, rocks, chemical, and noise should be exceed 60 dB. The pressure should be low with reduce the surface pressure tires, which allow a maximum traction. For maintenance, the machine have to maintain for once a year, and the part which needs maintenance such as the place for lubricate or inspect the conveyor chain, shaft alignment, and special shaft part. For ergonomic, the machine is convenience to hold, to handle, operate, and store. It is easy to set up and capable operate by one person, no sharp end. The cleaning machine must be covered in order to reduce danger to user and avoid any accident occur, as the mechanical component may cause an accident. The user age must be above 18 years old and below 55 years old. The recommended user gender is for men only. For the appearance is the machine must be present an image of robots, reliability, compact, and safe to use. The component of the machine can be visible from the outside and completely covered. Then, for finish, auto corrosion coating to protect the product surface in order to enable usage in the harsh environment. So the color of cleaning machine cannot be dark so that the people can alert during the operation in the night. For the quantity, the machine must have a high effectiveness, high precision, not easily damaged by impact or high rust resistant, durable, and high strength. For reliability, maximum is 2% failure rate over the service life. For the packaging, standard pallet to operate ISO standard to protect the machine. And for industry standard, the product intended to release in Malaysia only. The location is in the beach and the position is on the sand. This type of connecting provided at the back of this cleaning machine vehicle is a pin connection of kingpin. So the vehicle speed cannot be too fast, around 10 km per hour, and the product should not complete the standard ISO 9001. For the testing, the practical test on the machine function, vibration testing, corrosion testing, and acceleration life. For the safety, no sharp end and edge should be capable of being set up with the glove hand, and the connector and joint must connect well and ergonomically. So the machine should be produced according to the standard of NOSHA. So the market constraint is within Malaysia. Time scale product development is approximately 3 months, and the manufacturing facilities is cutting, drilling, welding, grinding, milling, joining. The tools are available. For the process, mass production due to the demand is high and the shelf life store. After leaving the factory of workshop, product can stay uninstalled and unused for 6 years. For the company constraints, none of this stage. So that's all for me. Thank you.
Hi, my name is Yeong Sook Yee, and this is the diagram represents our function structure for beach cleaning machine. And the function structure is a mechanical devices by the arrangement of function blocks and flow arrows. And this is our morphological chart for beach cleaning machine. And this morphological chart is a table-based functions for idea generation. In this beach cleaning machine, we focus on several main functions, which are include prime mover, collecting, conveying, separating, containing, and removing. And also 6 ideas are generated for each function. This is our first concept design from Chuan Ting. This design is a manual pushing machine, and it uses shaking method to transfer the rubbish from beach after the rubbish is collected by the rack. And metal frame is the housing of machine. The second design is from Poh Tsu Wang, and this design is using a beach truck or vehicle to push the machine. And it will use conveying method to collect and transfer the beach rubbish. Net window is the housing for conveyor, and the whole machine is covered. The third design is from Kai Boon, and this design uses a controller to move the machine, and it will use conveying method to collect and transfer the beach rubbish. And also vacuum suction method is used to separate the smaller particles of rubbish, and the whole machine is covered. The fourth design is from Yeong Sook Yee, and this design uses the Bluetooth to connect the user and machine, and conveyor act as the prime mover, and also a solar system and battery are used to provide energy to the machine. And last, it uses the conveying method to collect and transfer the beach rubbish. The fifth design is from Hazirah, and this design uses the pulling method to move the machine, and also it uses conveying method to transfer the beach rubbish, and a solar system and battery are used to provide the energy to machine, and also the whole machine is covered. By using the evaluation matrix from this diagram, we found that the concept design 3 from Kai Boon has the highest total score compared to other concept design. Hence, it will become the datum for the modified concept. The diagram shows the concept design 3 from Kai Boon, and we will modify the machine based on this design. This is the first modified design from Chuan Ting, and this design will remove the vacuum and push to move the machine. Also, the rack is updated to net shape, and brush is added between the corner of the metal frame. The second modified design is from Poh Tsu Wang, and this design removes the vacuum, push to move the machine, and also 2 conveyors are used to transfer the rubbish and collect the rubbish. The third modified design is from Kai Boon. This design removes the vacuum. 2 conveyors are used to collect and separate the beach rubbish. The fourth modified design is from Yeong Sook Yee, and this design modifies the rubbish separation part. And rack is changed to net shape, and also the bigger size of rubbish will separate by using the metal frame by rotation of 90 degrees. The fifth modified design is from Hazirah, and this design removes the vacuum. Sand is separated from the collected rubbish by using the shaking method. A proof matrix is a selection method to use to compare and select the best solution from a set of alternative proposals. And from the proof matrix as shown in this diagram, we found that the modified concept design 1 from Chuan Ting has the highest total mark. Hence, the modified concept design 1 is selected as our group final product design. This is our group final product design for beach cleaning machine.
Assalamualaikum and good evening. So my name is Hazirah Binti Roslan. So I will present you about the design embodiment. For design embodiment, there is a 3 part, which is initial design embodiment. The second one is DFMA design. The third one is DFMA table. So for initial design embodiment, there is a 2 part, which is material selection and detail sketches. For material selection, we choose, there is three main material selection, which is with my steel, stainless steel, alloy steel. For my steel, the component that involved is frame structure, handle, drawer, motor base, pocket, and so on. For the stainless steel, there is bolt nut and washer, pillow block bearing. For alloy steel, there is a roller chain. So let's move on to the detail sketches. You can see this is the final design for our group. This is our sketches. The detail I will give below. I will give later. So this is the boom list of our final design, which is a rear wheel. We choose to have a quantity 2, rear wheel shaft 1, pillow block bearing 4, frame structure 1, motor sprocket 1, castle wheel 2, motor 1, roller sprocket 4, drawer 1, roller chain 1, net collector 1, and so on. So let's move on to the DFMA design. So DFMA design we divide for four section, which is the number 1 is prime moving, number 2 is collecting and separating, 3rd one is conveying, and the 4th one is containing and removing. For the prime moving, this is design sketches for before. As you can see here, that before we use a lot of bolt, nut, and washer, and after DFMA we reduce the bolt, nut, and washer by welding the handle part, square part, and rectangle part together. So second one is collecting and separating. So for collecting separating, this is design before. As you can see, there is egg part, which egg component here for collecting and separating. So after the FMA, we reduce it to 3 parts only. Let's move on to the conveying. So for conveying, this is before design. This is before around 18 part here, and then we reduce to 12 part. We reduce here is long plate, short plate, screw, washer, and nuts. So the last one is conveying, containing and removing part. For containing and removing part, this one is the final design. And then this is after. So as you can see, there is a lot of part that we can reduce it. For example, there is no drawer slide, roller rail, roller wheel, cabinet shoes, roller rail for right and left. So the last part is the FMA table. So this one is the FMA table. For first part is prime moving. For total before the FMA is 63. After the FMA, we get 39. So total is we reduce around 24 for bolts and nut after we decide to welding it. And the second one is collecting and separating. The total for collecting and separating before the FMA is 16. After the FMA, we reduce until 4. So as you can see here, there is we reduce L bar, 5 quantity, nuts, washer, straight bar, and bolts. The third part is conveying. Total conveying from the design is before the FMA is around 16. After the FMA, we get only 42. So we reduce around 60 part. And the last one is containing and removing. The total quantity for containing and removing part is 19. After reduce, we get 3 only. So we reduce around 6 part, which is drawer slide roller rail, roller wheel, drawer or cabinet slide roller rail, drawer slide roller rail, and the 6 is cabinet slide roller rail. So overall is around 158 before the FMA. we reduce until 88. So there is a reduction in part around 68. So after we calculate, we find out that the DFMA for our design is only 44%. So since potential is 40 to 60%, so indicates that the current design is fair. So thank you.
My name is Kai Boon. So now I'm going to present the failure mode and effect analysis (FMEA). FMEA is conducted to determine the possible failure mode, effect, potential cost, also along with the relatively recommended action in order to mitigate the failure. First of all, for the moving primer, the potential cost is the surface of wheel is too soft and it will cause the surface of wheel damage. The recommended action is use the surface of material that can withstand abrasion in order for the machine to move properly. Our beach cleaning machines require the user to push the machine by using the handle. Thus, it may cause unsuitable posture for user. The recommended action is do ergonomic analysis to find suitable height and posture of worker based on anthropometric measure of Malaysian. Another potential cause of failure is too much force on the shaft. Rotations of rear wheel shaft cause load fluctuations which will contribute to fatigue failure in shaft. Thus, the potential failure effect is deflection of shaft or broken shaft. The recommended action is do engineering analysis on the shaft to determine the safety factor based on the Goodman line and gear line. However, if found the shaft will fail under the fatigue load, suitable actions such as changing the diameter of shaft or material of shaft will be taken. The result of the engineering analysis will be discussed after this. Also, overloading or due to too much force exerted on the frame will cause the frame deflect. In this case, we will use simulation analysis to determine whether the force exerted on the frame will cause deflection of frame. Another sub-assembly is collecting. If the speed of the conveyor is too fast, it will cause the rack fail to collect the rubbish from the sand. The recommended action is to determine the speed of the conveyor chain by choosing the suitable speed from motor in order for the conveyor rotate at constant speed. The next sub-assembly is the conveying part. Failure of motor will cause the effect of sprocket stop turning. Hence, we need to ensure that motor have high reliability with at least 99.9% reliability. Moreover, the potential cause of failure and potential failure effect for the shaft on the top and bottom of the conveyor is same as the rear wheel shaft. Thus, we will do engineering analysis in this critical part and the result will be discussed later on. Uncontrolled vibration that occur in chain is caused by the high speed combined with small sprocket. This can be avoided by determining the suitable chain by considering the rotary speed of sprocket T based on the guideline from supplier. Moreover, use raw lubricant method or do not provide suitable lubricant can cause the effect such as malfunction of chains. Hence, the recommended action is follow the guideline from supplier by using the correct method to provide suitable lubricant. Next, for the separating part. The sand gets stuck during separating due to the honeycomb gap is too small. Therefore, we need to ensure that the gap is sufficient enough to filter out the sand. Moving on, for the containing part, the drawer stuck and cannot open and close properly due to the ball bearing fell out of drawer slider. Therefore, we use another concept which shown in the figure below instead of drawer slider that require the ball bearing. Last but not least, the ergonomic analysis for the removing part will discuss later as it needs the user to pull out the drawer manually which requires suitable posture for worker. In our beach cleaning machine, the motor of the power that we are going to use is 1.5 kW and the speed is 900 revolution per minute. The function of this motor is used to move the conveyor. From the selection of chain, we follow the guideline of Misumi chain catalog. At the end of the selection, we select the CHE35 single chain in our machine. Also, from the guideline, Type B lubricant is required. The largest sprocket can dive into an oil bath. The majority of chain drive and conveyor will perform better and last longer when timely and adequate lubricant is provided. From the engineering analysis, the safety factor based on Goodman line and gear line for the shaft on top and bottom of the conveyor and the rear wheel shaft is greater than 1. It indicates that the shaft will not fail under static loading and it has infinite life. Simulation analysis on frame structure is performed. The frame structure of the beach cleaning machine is the most critical part as many components such as top roller, bottom roller, and wheel are attached to the frame. In the simulation analysis, a maximum 10 kg force is exerted to the top surface of the frame. Arrow 1 is the most critical part among the whole structure as it is facing approximately 2.782 times the 10 power of 5 pressure of stress. Overall, the frame structure is strong and solid as it did not exceed the yield strength, which is 2.412 times 10 power 8. For the ergonomic analysis on removing part, based on anthropometry of Malaysian young population, average knee height is 50.4 for male. The knee height of 50 percentile is 50.7 cm. The user of this machine is for male user according to the PDS. The reason we refer to the knee height is because when people squat down to pull out the drawer, it is the height and the best position for their hand to pull out the drawer. The decision of the design is the distance between the bottom of the drawer and ground is 310 mm. The total height from the ground to the above of the drawer is 510 mm. It is the best height as we still need to consider the height of the conveyor part and in order to avoid the collecting part crash to the drawer until it cannot function properly. The last part is the ergonomic analysis on handle part. Based on anthropometry of Malaysian young population, average standing shoulder height is 138.5 for male. The shoulder height 95 percentile is 150 cm and for 5 percentile is 131 cm. The decision of the design is a maximum height for handle is 140 cm and the minimum is 101 cm. Handle can be adjustable according to the operator comfortability. In order to make sure the operator side is clear so the maximum height of the bead screening machine is 140 cm. That's all from me, thank you.
Okay, good morning to Dr. Hairu. My name is Ting, and now I'm going to present the SolidWorks models of our bead screening machine. As you can see, this is the final concept, the final design of our bead screening machine. So we separate this bead screening machine into different parts. The first part is the prime mover, and the second part is the collecting and separating. The third part is the conveying system, and the next is the container and remover. So for the prime mover, we are manually controlling this bead screening machine, which means the user will push this bead screener along the bead, and we are using caster wheel for this machine to ease the turn rate for the user, which means the user can easily turn the bead screening machine to the left or to the right. And next is the collector and separator. So for the collector and separator, we are using the net collector for this machine. The usage of the net is to filter out the sand when the rubbish is being collected and being conveyed to this container. Also, as you can see, the net collector is being welded onto this attachment, and then we come to the conveying system of this machine. So for this conveying system, there are two rollers. The first roller is a top roller, and the second roller is a bottom roller. So the motor will drive the top roller, and the top roller will drive the bottom roller when this machine is working. So in this conveying system, we are using two types of chain. As you can see, the first type of chain is the chain with attachment. This is the attachment. The usage of the attachment is to let the net collector to be welded onto the attachment. Second is the normal chain. This is the normal chain, and the motor will drive the top roller using this normal chain. And also, for the top roller, we use two pillow board railing, and the pillow board railing is being fastened onto the what we call is the top roller holding plate. This is the top roller holding plate, and the top roller holding plate is being welded onto the frame of this machine. And this is the support of the top roller plate. And next is the bottom roller. For the bottom roller, we use 2 pillow board bearing for this machine. Both of them is being welded onto the frame. And next, we come to the container and remover. This is a container and remover. We use a drawer for this container and remover. When the rubbish is being conveyed, eventually it will drop on this container. And when this container is full, you can manually remove the rubbish by pull out this container and clean the rubbish. Also, we come to the handle. So this is the design of the handle of our beach cleaning machine. As you can see, this is what I call the handle support. The handle support is being welded onto the container and the frame. And this handle can be adjusted according to your preferred height by adjusting the holes. So next is the cover. The usage of this cover is to prevent the rubbish being flew out when the collector is collecting the rubbish. So also the base motor plate. This is the base motor plate. The base motor plate is being welded on this frame structure. And for the back wheel, the pillow board of the back wheel is also being welded onto the frame. So now I'm going to show you the side wheel of our beach cleaning machine. Okay, so this is the side wheel of the beach cleaning machine. As doctor can see, the wheels of this machine is parallel, and the net collector is not exceeding both of the wheels, which means when the rubbish is when this machine is working on the beach, the net collector will not being crashed onto the ground of the beach. And from the side view, I can explain to you how this machine works. So first of all, the user will push this beach cleaning machine along the beach. And when this beach cleaning machine meets some rubbish, this collector will pick up the rubbish by scooping the rubbish out. And then the conveying system will convey the rubbish and transfer them into the container. And eventually, the user can remove the rubbish by manually. So this is the SolidWorks models of our beach cleaning machine. Thank you. For the costing part, the estimated cost stated in product design specification is 1,100 ringgit Malaysia. But based on our calculate cost, as you can see from the table, the calculate cost was 1,022 and 20 cent ringgit Malaysia. Based on the calculate cost, we can say that this machine fulfilled the estimate cost stated in product design specification. So in conclusion, modified concept 3, which is Chuan Ting concept, score the highest among the 5 modified concepts, which means it is the most suitable beach cleaning machine to be developed. So this machine can perform well in cleaning the rubbish from the beach. So this machine has fulfilled the objective of this project, which this machine can clean the rubbish from the beach in Malaysia. That's all from me. Thank you.